Good afternoon, students and future aviators alike. We are Airbus One and who we are. So let's talk a little bit about who we are for a minute. We are a group of aviators. It's myself, Chris, Daniel, and Francisco. And we are, like I said, we're a group of aviators, and we heard that you guys all have an interest in aviation. So that's why we came down to you today. We're going to talk to you about 4 principles of flight and how they intertwined to keep an aircraft in the air. And the goal of our lecture today is to just inform you on these principles of flight and spark your interest a little bit more in aviation, and maybe help you out in figuring out, what field you possibly want to go into, whether that may be propulsion or just aerospace and flying or aerodynamics. Um, it might help you out today. So now that you know what we're going to talk to you about, let's get right into our first principle, and that is drag. I'm going to talk to you a little bit about drag. So drag is one of the more simple principles other than thrust, lift, and weight, which we're going to talk about here in a minute. Drag is simply the friction against an aircraft that is opposing thrust. So sciencelearn.org defines drag as exactly that. It's the force working against thrust is called drag. It is caused by air resistance and acts in the opposite direction to the motion. The amount of drag depends on the shape of the object, the density of the air, and the speed of the object. So you can compare drag to an aircraft as you can to drag on a car. So, if you're driving on the highway at 75 miles an hour, if you've ever rolled your windows down to catch a breeze, you hear and feel that wind blowing against your car. It's the same thing in an aircraft. So when you take off, your engines produce thrust and slowly lift the aircraft up, and along with all the other principles of aerodynamics, get you off of the ground. Now, that air that's blowing against the aircraft that's opposing thrust, that is called drag. So the more drag you have and the less thrust, you're going to lose speed. And vice versa, the more thrust you have with less friction or drag, the faster you're going to go. So pretty easy principle. Now that you know a little bit about drag, let's move right on into thrust, and Daniel's going to talk to you about thrust.
Thanks, Greg. Good morning, everyone. My name is Daniel, and I've been working in the aviation field for quite some time now. Understanding how aircraft stay in the air is based upon 4 key rules of aerodynamics. Since now you know a little bit more about drag, I'm going to explain the role of thrust. Thrust is basically the opposite force of drag. So the output force of thrust must be greater than drag. For example, a glider that provides no thrust simply uses drag to stop itself. But if you have a small aircraft, it gets its thrust from the propellers or the turbine engine, which keeps the aircraft moving in the air. According to McLean, he states that propulsive effort can be applied in a variety of forms: rotating propellers, flapping wings, complicated processes inside engines, and so on. That being said, many different aircraft manufacturers may use different varieties of engines or propellers. So let's say you're on a commercial flight and the aircraft is coming in to land. The pilot simply cuts back the throttle, decelerating and losing thrust, and allowing drag to slow down the aircraft. You also may see speed brakes opening, closing, which increases drag, reducing the amount of thrust. You'll also notice the flaps lowering, which increases the amount of lift. But Francisco will be talking to you more about lift, so let me turn the floor over to him.
Thanks, Daniel. Now I would describe lift. According to the Glenn Research Center at NASA, it describes the concept of lift as the force of an object when it passes through a liquid, fluid, or gas. Now, it's kind of hard to understand that, but just bear with me. Let's say that my hand is the airplane, and these are the contact surfaces. Every contact surface on an airplane generates lift. Now, if the airplane passes through any opposing force, such as air, oxygen in this case, it's going to bounce off those molecules at a molecule level. it's going to generate lift. For an airplane, in this instance, the majority of the lift is generated by the wings, and we can imagine that as my fingers being the wings, obviously smaller wings, but imagine bigger wings, it'll generate more lift, thus more of an upward motion. Lift ties into the concept of aerodynamics as one of the points also with thrust and drag. Now, when you think of lift and you think of drag, an airplane would have ailerons to slow it down on top of the wings. So pretty much it slows down the effect of lift. It's going to displace the air in a downward motion. And on the other hand, if you add thrust to lift, it's going to create more force, therefore more lift. Now, lift can be generated in the air and also underwater. It's pretty much by definition an object hitting another object, such as a fluid or gas. Underwater, pretty much you're displacing water, so you're going to produce lift. In regards to space and with the space shuttle wings, there really is no lift in space because that's more of a gravitational force that is created by the Earth and the space shuttle, keeping it in orbit or in the direction that it's going. Space is just a vacuum, so there really is no opposing force where the space shuttle can produce lift. This also, by definition, could be if the object is passing through the opposing force, or if it's in a wind tunnel and the force is being applied through the object, such as a wind test tunnel. So the factors that affect lift are thrust and drag. One other key factor that affects lift is weight. And next to present is Chris to discuss weight. Here you go, Chris.
Aircraft weight plays a large part in not only aircraft design, but how its flight characteristics are, the maximum load it can carry on both cargo and fuel, as well as how strong components are, such as landing gear and structural supports. Egbert Torenbeek wrote a book on subsonic airplane design, and in it he explained, weight limits are established during the process of design, and certifications for airworthiness are laid out in the flight manual as well as documents associated with the certificate of airworthiness. This plays a large role in the design of aircraft, and if you take weight from the left side of the jet, you have to then replace it on the right side of the jet for weight and balance issues. If the airplane is designed too heavy or too light, they will not get their certificate of airworthiness, which is a big deal. It's a big deal to airplane manufacturers as well as the FAA for new airplanes designs that come into play. To counteract some of these issues, we utilize SpaceX technologies for aircraft to make them not only lighter, but to make them stronger and cheaper to produce. Fiberglass, carbon fibers, and alloys such as titanium, magnesium, and high-strength aluminum play a large role in aircraft weight and design. With composites such as carbon fiber and fiberglass being corrosive resistant and extremely strong, some airplanes have upwards of 50% of their structure made from it, while alloys are usually utilized in landing gear and engine configurations. And other alloys such as aluminum are used for the outer skin as well as structural support and keel beaming. No matter how or when the aircraft was designed, the weight is one of the most important factors, hands down. Drag, thrust, lift, and weight. They all have their own distinct roles in principles of aircraft flight and how it affects the aerodynamics of the designs of the plane. Whether you want to be an aerospace engineer, a jet engine mechanic, or are simply interested in aviation as a whole, these four concepts are what keeps our aircraft in the air. So the next time you fly or see an airplane, think of these four forces and how they're affecting the floating piece of metal in the air that we all ride in.